Can you guys hear me okay?
Yes, we can hear you, we can see you, and your slides are perfect. So you have your 5 minutes now.
Okay, thank you very much. So today we're going to talk about high output rate aerosol printing for high conductivity printed electronics applications. The first thing we're going to talk about is sort of the sweet spot for aerosol printing, the traditional sweet spot, and then we'll talk a little bit about what we're doing to enhance the aerosol printing capability and expand it into other areas. So the slides here show what a typical sweet spot for aerosol printing is printing of fine lines. A lot of effort for aerosol printing has been focused, no pun intended, on printing of very fine features. So we can reliably print features down to 15 microns in width, and a lot of our customers actually have printed features at 10 microns or less. The image on the right shows gold printed conductors. They're 20 microns wide at 100 micron pitch. And they have really good line edge quality. I can show you some better, higher magnification images of the type of line edge quality you would expect for our aerosol printing. Another unique advantage that we have for the aerosol printing is that we have a large working distance between the nozzle and the substrate that we're printing on. This really makes aerosol printing unique, or provides a unique advantage over a lot of the other digital printing technology used in printed electronics. So the printing standoff distance can be anywhere from 2 to 5 millimeters typically, and customers even recently have demonstrated 10 millimeter standoff distance with good print quality. And so one of the misnomers is we have talked about focusing of the aerosol stream, but in fact it's actually largely collimated as opposed to focused. So the large standoff distance gives us the ability to print over features such as the one shown here on the right. This is a 3D printed dome structure, and we've printed a strain gauge on here for one of our projects. And we did this with 3-axis motion control, coordinated motion control. Sorry for all the pop-ups. And then I'm going to step into what we're doing now to really enhance our output rate as we start to kind of move more towards production applications or being able to print larger features, and how we're doing that. One application that we're looking at is replacing wire bonding with the formation of stud bumps with printed bumps instead. This is particularly useful for people in the medical field where they're making medical devices or high performance electronic applications where the volume of a single design is small, or the throughput is, anyway, high mix, low volume applications. And so on the image on the right shows one of the stud bumps that we printed recently, and this is still under development, but the feature is about 40 microns tall and 70 microns wide on the bottom. And we've developed a unique ink formulation that allows us to kind of print these features with minimal overspray and get really good definition. And on these, the bumps would generally be printed onto the conductive or the printed circuit substrate, and then the integrated circuit would be flip chip bonded to using the bumps. Part of what we've done recently, we've actually looked at our ink formulations, and we've been able to increase our output rate by a factor of about 17 times by modifying and working with the ratings that are able to be pre-aerosolized at low viscosity, but also be able to output our printing technology. And then we also are some of the things we're looking at are at the high flow rates is also some better focusing capabilities. The image on the right shows a line we recently printed using some advances in our focusing capabilities. We were able to output these printed lines at 5 millimeters. Print speed is 5 millimeters per second, a single pass, and the line is about 15 microns tall and about 90 microns wide at the base. And we're able to demonstrate using this technique also to print features up to 200 microns in width. This is a significant advancement in our output rate, volumetric material output rate. I think this is like 5 million cubic microns per minute, I believe was the calculation. We're also continuing to make sure that the performance of the print heads remain consistent. The data on the right shows the typical tests that we're using on our print heads for qualification. and it shows that the average, this shows for a 68 micron printed line, we have an average standard deviation of the printed line width of about 3% over the 8-hour period, and the tolerance on that's about 5%. The lines in the upper right show the lines that were printed for this 8-hour test. The unique design for our printhead really avoids clogging, and what was typically known as satellites are largely eliminated with the printing technology. The images on the lower right show the printed types of printed line edge quality you would expect with the IDS NanoJet aerosol printing technology. In contrast, on the image on the right shows aerosol printing on a different technology from a different company that was more traditional. It was your original aerosol printing technology. So our technology, with the way we're focusing using multiple aerodynamic,
you have 1 minute, just to let you know.
All right, thank you. Allows us to avoid overspray and provides consistent, reliable, long-term printing performance. Because of the high output rate, we're able to print features like the one being shown in the video on the right. So we're able to print features that have substantial thickness at a high output rate. This is a coil that's being printed on an embedded medical device that's being used as a stimulator. And so the coils actually have 20 ohms. They take about 10 minutes to print, and they're used for both power transfer and telemetry for the embedded device. So you basically can power it remotely and read the signals back from a patient. So between the medical embedded device and the stud bumping application, these are two applications that we're looking at for the higher output rate printing technology. Thank you very much.
Thank you. Thank you for the presentation, David, and thank you for joining us. As always, it's really interesting to learn about the capabilities of aerosol printing, and amazing how, what kind of features one can